Hi, I'm Sue Taylor, Chief Curator for the New Mexico Museum of Space History, and welcome to this edition of Preservation Workshops. As you probably noticed in the first video, that image of the explosion of the atomic bomb at Trinity Site has been seared into everyone's brains. But this program is going to tell you that we live in a radioactive world and not from the bomb. It's been here ever since the Earth was created. One of the things that a lot of people don't realize is that radiation is all around us. This is a Geiger counter, and if you listen, those chirps are telling you that there is radioactivity going on in this house. You have it in your house too. It's called background radiation, and it is everywhere. Now, I have in my lap a Fiestaware Plate. You may remember this from an earlier program I did on using antiques, and I showed you how Fiestaware, especially the orange and red Fiestaware, is highly radioactive. Okay, you're hearing the background radiation again. Watch now. That's how radioactive your Fiestaware, especially if it's orange or red, is going to be. Interestingly enough, if you use Fiestaware, at least the old stuff dating from anywhere in the mid-40s up until the 1970s, you only are going to absorb about 2.4 millirems of radiation per year. And that's not bad. We're allowed 360 millirems. So you can continue to still use your orange or red Fiestaware. Just be aware that the uranium salt that was used to make the glaze, every time you scrape up the plate with your knife or fork, you're getting some of that, okay? That's one of the things that this program's going to talk about, though. We have in our bodies over 200 billion radioactive elements. We ourselves are radioactive. And I'm hoping that after this program, you'll be able to talk a little bit more about radiation, what it is, how it helps us, and the next time you're sitting next to someone, you can say, oh, by the way, I'm radioactive, and see what their reaction is. Let's get started. Discovered in 1972, scientists found the remains of a natural nuclear reactor in a uranium mine in Oklo, Gabon, Africa. They determined that about 1.5 billion years ago, a nuclear chain reaction occurred in the mine. It generated heat off and on for 500,000 years. The real importance of this find was that the radioactive wastes left over from the, quote, reactor were found right where they were left more than 1 billion years ago. They hadn't moved or contaminated the area outside the mine. This was without having any man-made containers and the knowledge we have today to safely store and dispose of solidified nuclear waste. Mother Nature took care of it. We are all naturally radioactive. The human body contains billions of naturally radioactive atoms. Mostly they are potassium, a trace element needed for good health, and carbon, a basic building material of all living things. These radioactive elements are found in human bones and tissue. They help archaeologists estimate the lifetimes of ancient skeletons and mummies from around the world. Remember that this will be just an introduction to radioactivity, so I will not be going into any great detail. There are basically 4 types of radiation. Alpha rays, which can be shielded by paper or your skin. Beta, which can be shielded by thin metal or aluminum. Gamma, or X-rays, which are very strong, can be shielded by thick lead or steel plates. Ever wonder what that heavy covering is that they put over you when you go to get an X-ray? The last is neutron rays, very high energy, and can be shielded only by water or concrete. We are what we eat, and everything on Earth contains trace elements that are slightly radioactive. Yes, bananas are radioactive due to the potassium content. You will not die of radioactive poisoning by eating bananas, unless you eat 10 million bananas all at once. The same goes for avocados and Brazil nuts. All are slightly radioactive, but they are healthy for you. Just don't go overboard by eating thousands of pounds in one sitting. How many of you use salt substitute? That is what this is. Potassium chloride is used to substitute for sodium chloride, or salt. Hold a Geiger counter up to a pile of salt substitute and it will chirp. I know. I used to use it in demonstrations. Even your drinking water contains radioactive elements. The U.S. Environmental Protection Agency's drinking water standard for uranium is 30 micrograms per liter. Look for the amount of radon in your water. Is this bad? No, trust me, the chlorine is worse. We also get radiation doses from cosmic radiation. Showers of high-energy particles occur when energetic cosmic rays strike the top of the Earth's atmosphere. The higher in elevation that you live, the less air you have above you to block the radiation. At sea level, you will only receive 26 millirem of cosmic radiation. At 9,000 feet elevation, you will receive 96 millirems. Most cosmic rays are atomic nuclei. Most are hydrogen nuclei, some are helium nuclei, and the rest heavier elements. Although many of the low-energy cosmic rays come from our sun, the origins of the highest energy cosmic rays remains unknown and a topic of much research. This drawing illustrates air showers from very high energy cosmic rays. The type of house you live in also emits radiation. If your house is constructed of concrete, such as the Paso del Norte Hotel in El Paso, or adobe, like this wall, or stone, like the Carrick Furnace in Pennsylvania, or brick, like Tarpley's store in Williamsburg, Virginia, you are exposed to approximately 7 millirem per year. How about the little frame house to the right of Tarpley's? Believe it or not, buildings constructed of wood contain very little radioactive traces. Did you know that plain old dirt contains uranium? The mass concentration of uranium in soil varies widely, but is typically about 3 parts per million. A square kilometer of earth, 30 centimeters deep, will typically contain a ton or more of uranium. In the United States today, the concentration of radioactivity in uranium ore bodies is on average about 0.3% by weight. A very common item in your home is your smoke detector. This is probably a very important life-saving little gadget.
ionization smoke detectors use a small amount of radioactive material, americium-241, a source of alpha radiation, to detect smoke. An air-filled space between two electrodes creates a chamber that permits a small, constant current to flow between the electrodes. If smoke or heat enters the chamber, the electric current between the electrodes is interrupted and the alarm is triggered. This smoke alarm is less expensive than other designs and improves the original smoke alarm by measuring more than the heat of a fire. It can detect particles of smoke too small to be visible. If you fly, you are receiving 0.5 millirem radiation per hour that you are in the air. Remember, at 30,000 feet, you are closer to the cosmic radiation. Before you even board the plane, you are receiving 2,000 millirems radiation being put out by the luggage inspection station. Some of you may remember when watch dials contained radium to glow in the dark. That radium was applied to the dials by women using very fine paintbrushes. They would put the brush tip into their mouth to moisten the brush to a point, dip it in the radium, and apply it. The process was repeated throughout the day. On top of that, these young ladies, known as the Radium Girls, thought, what fun to go out on a date and apply the radium to their lips, eyebrows, and eyelashes so they would glow in the dark. Needless to say that their health suffered. This was much worse than putting Gorilla Glue in your hair. Even if it's not radioactive, you should still not do it. Due to the harmful effects of radium, it was replaced on watch dials today by less bright but less toxic compounds. Still, if you wear a luminous wristwatch, you are still receiving 600 millirems radiation. People believe that there is no threat of radiation from coal-fired power plants. Not true. Coal is also radioactive, and if you live within 50 miles of a coal-fired power plant, you are being exposed to 300 millirems of radiation. However, if you live within 50 miles of a nuclear power plant, you are only being exposed to 100th millirems. Interesting, yes? How about camping? You probably use a gas lantern such as this, which is lit using a cloth mantle that may be soaked with thorium. Using a thorium mantle every weekend for a year would be 0.3 to 0.6 millirems, tiny in comparison to the normal annual background radiation dose of around 240 millirems. Although this assumes the thorium remains intact rather than airborne. A person actually ingesting a mantle would receive a dose of 200 millirems. However, the radioactivity is a major concern for people involved in the manufacture of mantles, and an issue with contamination of soil around some former factory sites. One potential cause for concern is that particles from thorium gas mantles, quote, fall out over time and get into the air, where they may be ingested in food or drink. These particles may also be inhaled and remain in the lungs or liver, causing long-term exposure exceeding the risk of background radiation. Also of concern is the release of thorium-bearing dust if the mantle shatters due to mechanical impact. All of these issues have led to the use of alternatives in some countries, usually yttrium or sometimes zirconium, although these are usually either more expensive or less efficient. Coleman has subsequently switched to using yttrium for their mantles. Believe it or not, if you have porcelain crowns or false teeth, You have 700 millirem of radiation in your mouth. At least your dentures are not as painful as George Washington's were. No, they were not made of wood. They were made of slave teeth, as well as other materials such as hippopotamus ivory, brass, and gold. The dentures had metal fasteners, springs to force them open, as well as bolts to keep them together. I have seen these originals. Ouch! If you have a heart pacemaker, chances are that it's being powered by plutonium. You are being exposed to 100 millirems per year. That is part of your total 360 millirems for the year. Again, is that bad? No. Your body will adjust to it. Nuclear testing and radiation in our world has led to advances in medical science such as pacemakers, CT scans, and even the use of radioiodide 131 to treat cats that have hyperthyroidism. I had 2 cats that had to undergo the treatment. The first time, when the vet found out I had a Geiger counter, he asked us to create a chart of how long it would take the cat to reach background once she came home. He has used that chart ever since for other patients so their owners can know when it's safe to have their kitty sit in their lap again. You hear quite a bit about plutonium-238. It was the first isotope of plutonium to be discovered and is used for multiple applications, from medicine to space exploration. Radioactive plutonium is the fuel used for radioisotopic thermoelectric generators, or RTGs, that had been used in more than 25 space missions, providing power for Voyager 1 and 2, several Apollo missions, like Apollo 14 pictured here, Galileo, Nimbus, and LES. RTGs are generators attached to a spacecraft that supply power and heat. As the isotope decays, it gives off heat, which is used to generate electricity, a process known as thermoelectric conversion. The decay heat warms one end of the thermocouple, and the cold environment of space cools the other. This produces an electric current that powers the spacecraft. Excess decay heat is also pumped through the spacecraft system to warm up its instruments and subsystems, allowing it to operate in cold environments. RTGs have enabled major scientific accomplishments, including the Cassini spacecraft and Huygens probe's exploration of Saturn and Titan, one of its moons, since 2004. The landing of the Curiosity rover on Mars in 2014, and the flyby images of Pluto from the New Horizons mission in 2015. NASA is now working on new RTG technologies capable of generating even more electricity with less fuel. An advanced, multi-mission radioisotope thermoelectric generator, or MMRTG, is being used right now on Perseverance, the new Mars rover, which will be landing in 2 days. The next time you go grocery shopping, look for this symbol on your food packaging. It tells you that your food item has been irradiated. Irradiation kills bacteria, molds, and parasites in our food. Allows for food to be stored for an extended period without refrigeration, which increases their availability in underdeveloped countries. Using lower doses of ionizing radiation can lengthen the refrigerated life of fresh fish and chicken for several weeks. Strawberries treated this way can last for about 30 days. Sealed treated foods, like canned goods, can stay on your shelf at room temperature for years. Is it radioactive? No. Will it harm you? No. Is your food safe? Yes, definitely. and the nutritional value has not changed. Very few people know that radiation plays a significant role in transforming the colors of gems. Gemstones can be enhanced from their natural condition by irradiation. Diamonds change from off-white to green or yellow. Pearls change to blue and gray, quote, black pearls. And topaz changes from colorless to blue, like the ones pictured here. Radiation is used to toughen the rubber in radial tires and to align the steel belts in those tires. Even in the museum world, radiation plays a significant role. Since the 1940s, radiocarbon dating allows scientists to determine the age of a wide range of materials, including fossils, cave paintings, parchment, and even human remains, by examining the types of carbon atoms they contain. Carbon-14 is naturally created when high-energy cosmic rays collide with nitrogen atoms in the atmosphere. But the powerful above-ground nuclear bomb tests of the mid-1900s created even more carbon-14 isotopes out of that atmospheric nitrogen. In fact, so much carbon-14 had been created in the decade or so leading up to the signing of the Partial Nuclear Test Ban Treaty of 1963 that levels in the atmosphere virtually doubled. That increase in carbon-14 was reflected in anything that lived or died after 1963, including wood and fibers that might make up the support or canvas of a modern work of art, or the organic matter used to bind pigments in modern paint. Technological advances enabled researchers to analyze hair-like strains of canvas fiber a few millimeters long and a paint sample that measured about half a square millimeter in area from a known forgery, a painting of a 19th century village scene pictured here that was claimed to have been created in 1866. In reality, the work had been painted in the 1980s by Robert Trotter, an artist who was later jailed and fined for selling dozens of such fakes. As you can see from this radiation dosage chart, bananas are being shown as being very low on radiation. Humans usually receive an annual radiation dose from external sources of 360 millirems per year. However, it is not uncommon for any of us to receive far more than that in any given year, largely due to medical procedures we may undergo. International standards allow exposure to as much as 5,000 millirems a year for those who work with and around radioactive material. If you want to know your annual radiation dose, go to the American Nuclear Society's website, www.ans.org/nuclear/dose chart/ and use the interactive chart there to see what your dose is. It's fun.
Well, I hope you enjoyed that. I bet there were a lot of things you did not know that you use on an everyday basis that are radioactive. And even you are radioactive. But that's okay. Radioactivity is not a bad thing. It's useful in everything that affects us in our lives. It's useful in medicine, in sterilizing our medical instruments, even in irradiating our food so we don't have food poisoning breakouts like with salmonella. That is why knowing what radiation is and how it works for you is a very good thing. Even if you have Fiestaware like this in your house. If it's new, no worries. If it's not, remember 3 things when dealing with radioactive substances: time, distance, and shielding. The longer you are exposed, the worse. Shielding. Alpha particles can be stopped by your hand. It's gamma particles that you need a very thick lead protection. In fact, if I were to hold up the Geiger counter again to the plate, this wouldn't stop chirping until I put it under the chair. Then it will stop chirping. Distance is also important. The further away you are from something, the better. Just remember this. If you are radioactive yourself, just think, you can now say to someone sitting next to you when we get over the COVID that, hey, I'm radioactive. How about you? It's one way to start a conversation. And then you can go on to say, did you know we live in a radioactive world? Thank you for joining me, Sue Taylor, Chief Curator, for this edition of Preservation Workshops. If you'd like to, please go online to the New Mexico Museum of Space History's YouTube channel or to the Facebook page. There you will see other videos as well, kitchen chemistry, archives, and even some other interesting things, including other preservation workshops. Thank you for joining me today. It's February. It's still cold out there, so stay warm, stay safe, and stay well.